Good morning, student. In the last lecture, we are calculating the electric field for for a dipole at axial line and equatorial point or equatorial line. Now we are determining the electric field due to dipole at journal point. For this, I am making a diagram for to understood how we calculate the value of electric field due to a dipole at for a journal point. So first we are taking a small electric dipole AB, where on A minus Q charge is placed and on B plus Q charge is placed. Now when we rotating it by a small angle, then we are observing the condition for the dipole is A to be like this, and it will making an angle with the dipole. This angle is called alpha, which we use here, and the point where we need to calculate or determine the value of electric field is r meter distance from the center of the dipole O. So the point OP is r meter distance at where we need to determine the value of electric field due to dipole. So we can resolve this vector, or we can use the vector component or rectangular vector component of this electric dipole moment P. Now we take the P1 is the direction of OP and the P2 or dipole moment P2 in the direction of OB, जो कि इसकी actual direction है. Now by using the vector resolution, we are making the rectangular component of the electric field produced by this dipole at point P. So we are getting the horizontal component is this E1 cos theta, and this is perpendicular to the line, so it is vertical component E sin theta. By using vector resolution by rectangular rule, we are getting the resultant direction of this dipole is the diagonal of the rectangle, and this will make the angle alpha with the horizontal direction of electric field. Now we are going to deduce the formula for it. Okay. Consider a dipole AB of dipole moment vector P from center of dipole at r distance P is a point where electric field due to dipole is determined. Now from figure we are getting OP is R from O to P, and POB, angle POB is angle theta. Now by using the electric field component in the direction of C, D, E, horizontal rectangular component of triangle PDEC, we are getting horizontal component of electric field is E cos theta, and vertical component E sin theta. Now electric field due to dipole, electric field due to dipole at P in axial P on axial line of dipole is E on axial, we are saying this E1, that is 1 upon 4 pi epsilon naught P cos theta upon R cube. 2p cos theta upon R cube, because you are know about the value of dipole at axial is 2p upon R cube. This is your equation first. And electric field due to dipole at P on equatorial line is E2 is equal to 1 upon 4 pi epsilon naught P sin theta upon R cube. This is equation second, student. Now we are calculating the net electric field at point P due to dipole for a general point. Therefore, net electric field at P is given by E is equal to E1 plus E2. Equation third, and the magnitude of electric field at P is given by E is equal to under root E1 square plus E2 square. Therefore, by using these value from equation first and second, we are getting 2p upon 4 pi epsilon naught r cube cos theta whole square plus p sin theta upon 4 pi epsilon naught r cube whole square. So student, here the value which I am marking by the red ink marker is common, and this common thing has a square, so it will be taken out from its square root. So we are getting this value is equal to p upon 4 pi epsilon naught r cube under root square of 2 is 4 cos theta is cos square theta and plus p plus sin square theta. This is the field. Now we are resolving this here. This is first, then after this is second, and now we are solving this value to here. That is, I am giving the point is third. So by solving this, the electric field is p upon 4 pi epsilon naught r cube in under root. Student, we okay, here I am using till. Okay, first student, this copy to your notebook. Okay, now this third point is E is equal to P upon 4 pi epsilon naught r cube inside the bracket. We are using in place of 4 cos square theta, we are using this 3 cos square theta plus cos square theta plus sin square theta. Student, you all know the value of cos square theta plus sin square theta is 1. Therefore, p 4 pi epsilon naught r cube in under root, this value become 1 plus 3 cos square theta. This is the electric field due to dipole at general point. Okay, student. Complete this. Now we are calculate the direction of the electric field at general point P by using this rectangle. Okay. The direction of electric field at general point, the direction of electric field at general point is determined by okay student, here we are having, this is rectangle and this is, we all know in rectangle the opposite sides are equal to each other, so we can put the value e2 sin theta for dp side of the rectangle on side CE. So this is also equal to e2 sin theta student. Okay, now we are using here the trigonometric ratio tan theta, because this is base and this is perpendicular, so we are using here tan alpha is equal to EC upon dp. Therefore, by putting this value, or we can say E sin theta upon E cos theta. Okay student, so we all know the ratio sin theta upon cos theta is tan theta, and this is cancel. But second thing is the value of electric field at the axial line is 2, which we are using here this value. We also saying this at this point, so we get tan alpha is equal to 1 by 2 tan theta. This is the direction of electric field at the general point by the dipole. This topic is here completed. Now we are taking some graph about the electric field due to the dipole and the point with respect to the distance increased. First copy this all. Okay student, okay, we have the three formula for the electric field. One is electric field due to a point. This formula is one upon 4 pi epsilon naught Q upon R square. Second, we have electric field due to dipole. This formula is 1 upon 4 pi epsilon naught P upon R cube 1 upon 4 pi epsilon naught p upon r cube inside the bracket 1 plus 3 cos square theta. Okay student, from the two formula we are finding the electric field is related with the distance for the point charge is inversely proportional to the square of the distance, while for the dipole it is, this is for point and this is for dipole, that is 1 upon r cube. This shows that the electric field due to dipole is deplete faster than the electric field. So ER graph for electric field. This is also called electric field versus distance graph for this. Okay. Graph for point charge and here we are using graph for a dipole. Okay, now graph for electric field due to dipole due to point charge is, we are using at the x-axis is distance and at the y-axis is the intensity of electric field. So we are using the electric field is moving as this form. This is the depletion of electric field with distance as square inverse relation with distance, and for the dipole it is faster depleting, बहुत जल्दी से गिर जाता है नीचे, like this. This is the depletion or gradually decreased value of electric field due to dipole, and these are the rules of the two cases. So we are writing here, in the case of dipole, in the case of dipole, value of electric field is depleted faster than electric field due to a point charge. Copy this, student. Now we are taking the relation between the axial electric field due to dipole at axial point and the equatorial point. Relation between electric field for a dipole at axial line and equatorial line. We know that the value of axial is 2p upon 4 pi epsilon naught r cube, and the value of equatorial is p upon 4 pi epsilon naught r cube. So student, by dividing axial and electric field at equatorial, we are getting 2 upon 1. So we are calculating from here value of electric field at equatorial is equal to 1 by 2 electric field at axial. This is the relation between the two fields, or we are saying that electric field at axial line is equal to 2 times of electric field at equatorial. Copy this. In the next lecture, student, we are discussing and solving some numericals based on electric field. Now, in the syllabus, the topic electric field is completed. We are doing today till this topic. Prepare, student, all the topics which we done earlier. One thing is very important, student. You need to complete your home assignment mandatory. So go through your student homework portal and find which homework is given to you. You need to submit your homework time to time as date given by the teacher. Student, this is also important because of CBSE guideline. The attendance of each student at the time of online classes is required 75%. If any student is not taking the online classes seriously, so it is difficult for them to complete their attendance. So please, I told you, all of you go for the online class such that you know about your home assignment, and the home assignment which we are making for you on the basis of the topic which we teach you in the online classes. So student, go through your online class video and complete your homework. If any of you having problem in the homework, then you are very categorically explained by us. You are place that numerical problem in your home assignment. We are go through with that in the next class. First we are resolving this those your problem, then we are going through the next topic. Thank you, student.